Okay, so in this video, I'm going to show you how to write an equation for a polynomial function from its graph. So this is one of the last few questions on the Delta Math. They're going to give you a graph and then they're going to ask you to write the equation in factored form. So the first thing you're going to want to do is look at the graph and see where it has x-intercepts, which are also called zeros. So if you look at this graph that I have right here, it has an x-intercept at -4 and it also has an x-intercept at +1. So you would start by writing the equation y equals, and I think it already has the f of x equals or the y equals, so the only part that you have to type is this second half. So first thing is, we have a 0 at -4, so that factor would be x plus 4. And then we have another 0 at 1, so that factor would be x minus 1. So remember, x-intercepts and zeros are the same thing. So x-intercepts are the same thing as zeros, and they're also called the real roots. And sometimes teachers will just call them roots, but the better phrase or terminology is real roots. So this is the graph so far, okay? Now the next thing that you have to do is you have to look at the multiplicity of each of the factors. So you'll notice at -4 that the graph is crossing through -1. So that means since it crosses, so it's crossing the x-axis. If it crosses, then it has an odd multiplicity. And what that means is the exponent, sorry, I spelled multiplicity wrong. The exponent on the factor is odd. So it could be 1, it could be 3, it could be 5. We just stick with 1. That's the easiest thing to do. Now you'll notice at 1, the graph bounces off of the x-axis. If it bounces off of the x-axis, then we know that the multiplicity, if the graph bounces, then the multiplicity is even. So you could use any even number like 2, 4, 6, etc. But the best thing to do is just to stick with 2. The higher you make the number, the harder it's going to be to find the y-intercept. So we're just going to use 1s and 2s. So if the multiplicity is odd, we're just going to use a 1. And if the multiplicity is even, we're going to use a 2. Now, obviously, if the multiplicity is odd, you don't have to put the 1 into Delta Math. If the multiplicity is even, then we're going to square it, okay? So now what we've taken care of so far are our zeros and our multiplicity. And I'll keep a list here for you. So the first thing we did was we dealt with the zeros, and then we checked the multiplicity. Now, the next thing we're going to do is check that our end behavior is right. So if we look at our function, the degree, when you're in factored form, you have to add up the exponents. If you remember degree from Algebra 2, the degree is the highest exponent, but that's only if you're in standard form. Now, standard form means you have something like this. So when you're in standard form, and actually let me get this out of the way. So hold on. I need this. I'm just trying to move that down. Okay, so if you're in standard form, you have something like y equals 4x cubed minus 5x squared plus 7x minus 11. The degree here would be the highest exponent, which is 3. However, if you're in factored form like our function is, then the degree is going to be the sum of all of the exponents, because technically what you'd have to do is multiply all this out. So the degree in our polynomial here is going to be 3 as well, okay? So we know that our degree is odd, okay? And we don't have to know that it's 3 necessarily. The only thing that matters is that it's odd. Now, the next thing is, if you have an odd degree, you have to also look at your leading coefficient. In standard form here, the leading coefficient would be +4. Since there's no number in front of ours, it's 1. And then also there's not a negative out here. So our leading coefficient, and I'll just put leading C so it's easier, is positive. So what we have is a positive odd graph, okay? Now, there's a table that you should have learned in Algebra 2 about end behavior, and I'm actually going to make that table for you right here real fast. This is in our notes that we took on Monday. Well, actually, We started the notes on Friday when you worked with the Desmos activity. I'm not sure if you completed that or not, but we were supposed to work on getting a table for end behavior. And then that's the first thing that we did on Monday is I went over that with everybody. So I'm not sure if you have that information, so I'm going to go ahead and do it for you. When you look at end behavior, you have to look at the leading coefficient, and then you also have to look at the degree. Now, the degree could be even or it could be odd. And then the leading coefficient could be positive or it could be negative. And this is not, I mean, this is something you need to memorize, but it's easier than memorization if you just think about a positive even graph looking like y equals x squared, because that's a positive even. That's a parabola. And if you know what a parabola looks like, you know that the end behavior is up, up. Then if you think about a negative parabola, that just flips the parabola down. So that looks like this. And that's going to have end behavior of down, down. And then if you think about odd graphs, the easiest one to think about is just a line. So like y equals x. If you look at the end behavior of y equals x, it goes down, up. And then lastly, if you have a negative odd graph, that's a negative looking line. So the end behavior of that would be up, down. So this table is something that you really have to commit to memory, because when you look and you see that you have a positive odd, you should know from the table that a positive odd, and that's this part right here, a positive odd has end behavior of down, up. Okay, so that means that my end behavior of my graph should be down, up. And if you look at it, it is. It's down, up. So what that means is my degree is correct, and it also means that I don't need a negative out in front of here. If it were up, down, I'd need to throw a negative in front, but I don't have that, so I'm good to go. All right, now, so let's see. We did zeros, we did multiplicity, and we did end behavior. And now the last thing that we have to do is we have to check that our leading coefficient is right. And I don't mean its sign, I mean if it's positive or negative. So we have to check that our leading coefficient is right. And the way that you do that is by checking the y-intercept, okay? So I'll put leading coefficient, y-intercept. So there's 4 things that you have to do here. Check your zeros, check your multiplicity, check your end behavior, and check your leading coefficient. So what I'm going to do is I'm going to look at my graph. And the y-intercept that I need is actually 0, 20. Okay, so what I'm going to do is I'm going to plug 0 into my function that I wrote every time I see an x. And I'm going to see what the y-intercept of my graph actually is. So if I plug 0 in for x in my graph, I get 4 times -1 squared, which is 4. Okay, so my y-intercept in my function is 4. It needs to be 20. So what that means is my graph is 5 times too small. So what I need to do is I need to multiply my whole function by 5. So what I do is just right in front of here, I throw a 5 as the leading coefficient. Now, I'm going to erase this so I can kind of get that in there so it's not confusing. So that's the last thing that you have to do is figure out what your leading coefficient is. And that should be the equation of your graph. Okay, so I'm going to grab one more and I'm going to do that one for you. And then you can give this a shot. So let me pause this and I'll grab another graph. Okay, so here's another example. I'm just going to kind of start by writing the zeros out first. So if you look here, we have a 0 at -3. That means that we need a factor of x plus 3. And then we also have a 0 at 1, so that we need a factor of x minus 1. Okay, so we did our zeros first. The next thing we're going to do is look at the multiplicity. You'll notice that at -3, the graph crosses through the x-axis, so it has an odd multiplicity, so we can leave that alone. But you'll notice that the graph bounces off of 1, so that has to have an even multiplicity, so we're going to go ahead and square it. our graph, if you add up the exponents, has a degree of 3. So our degree is odd. And right now, we have a positive coefficient. Well, if you look at the graph, the end behavior is up, down. And if you go back to the table, end behavior that's up, down is actually a negative odd. So we need to put a negative in front of here. Now I'm going to leave a little bit of room because I happen to know that there's a coefficient on this one. So I'm just going to leave some room because I know I actually have to put a number in here. Okay. So we did our zeros. I did the multiplicity and I looked at the end behavior and noticed that it's up, down. Well, up, down is actually a negative odd graph. Okay, so the next thing I'm going to do is I'm going to look at the y-intercept. Y-intercept on our graph is -4. And let's see what we get when we plug in 0 to our function. So if I put in 0 for x here and here, I actually get, now make sure you bring down this negative. So -3 times -1 squared. So that's -3. Well, I want -4. So I have to say -3 times what, so I'm just putting a variable there, is equal to -4. And if you solve this for the variable, which is a, you get a is equal to 4/3. And what that means is, so that you have the correct y-intercept, you actually have to put 4/3 in front of your function. And so that's the equation of your function. Remember, you have to get your zeros, your multiplicity, your end behavior, and if you go back to this table, that'll help you with end behavior. And then you have to check to see if you need a number out front so that you can figure out if your y-intercept is right. Now, one thing a lot of students in class were doing is if they had the function like this, I think I had it backwards, hold on, x plus 3 times x minus 1 squared, and it was negative, so I'll put that in there. When they were getting the wrong y-intercept, they were saying, okay, well, my intercept should be -4, and I'm getting -3. So they were just saying, let's move that down 1. Now, while that does get you the correct y-intercept, so if you just watch this, sorry, my dog's losing it. If you watch, this y-intercept is going to move down to -4. So just watch. Now, the problem with that is it moved all of the points down 1. Okay, so it changed your x-intercepts. So rather than moving your graph up or down, you want to multiply it by something. Because what that does is it changes your y-intercept, but it doesn't change your x-intercepts. So that's why you can't add or subtract to the graph. Okay, I hope this helps. Just email me if you have any other questions.